Earth is our familiar home, the world we know and understand. But this isn't the Earth where dinosaurs ruled supreme. Perhaps this isn't the Earth where Russia won the race to the moon, or the Earth where we could vanish in the blink of an eye. On the dimmest star, inside a black hole, hidden within higher dimensions, there exists another Earth. Now, groundbreaking science is beginning to suggest that perhaps there's another version of reality. Do parallel universes actually exist? Space, time, and life itself may be far more complex than we ever imagined. We will uncover the mysteries of the cosmos and explore one of the most profound questions in modern physics. Are there parallel universes? Do multiple versions of you exist? Do multiple versions of me exist? My other version might look identical, but they are fundamentally different. Our destinies could be completely divergent. One of us might even be descended from the other. It's possible that if we were to meet, we would both evaporate and transform into pure energy. Perhaps we are living more than one life simultaneously. Because as scientists delve deeper into the laws of physics and the nature of the universe, more and more of them are beginning to accept that parallel universes might actually be real. These alternate realities might even determine the fate of humanity itself. When I was in grade school, I was completely infatuated with a particular girl. She occupied my thoughts constantly, but I expressed all of this in a rather awkward, humorous way. My mind always wished that I could be completely different, filled with confidence and charm. I wanted to find that version of myself wherever he might be hiding in the fabric of reality. MIT cosmologist Max Tegmark believes that my ultimate version, and indeed alternate versions of all of us, truly exist. He argues that these other versions of ourselves reside beyond the universe as we know it. What is the universe made of? Our most fundamental theory about its composition suggests that it isn't just large. It's actually infinite, continuously expanding in every direction. Max believes this is a matter of statistics. But in an infinite universe, even the most bizarre events become not just possible, but inevitable. Consider this simple example. Imagine I have 3 stones here, creating a pattern of orange, white, and black stones. Look at this. Oh, here we have another set of orange, white, and black stones in the same arrangement. If I create a larger, more complex pattern here, I would have much more difficulty finding another identical pattern. But eventually, in an infinite space, it will repeat. Earth itself is just an enormous pile of stones and minerals. Our bodies are vast collections of atoms. The specific way these atoms are arranged in space determines who we are and what we are. The larger and more complex the pattern, the farther we must travel to find a repeat of that pattern. When I say that atomic patterns repeat, I mean every pattern without exception. This includes the pattern of atoms that makes up me, that makes up you, that makes up everything we see and experience. If I keep traveling outward through infinite space, I will eventually find a copy of myself. This copy won't just look like me, it will feel exactly like me, think like me, and have the same memories up to that point. Max has calculated how many light years away one would need to travel to find the atomic pattern that makes up himself. The number of light years required is staggeringly large. I discovered that to write out this number, I would need millions upon millions of zeros. This number is unquestionably enormous beyond human comprehension. But considering the size of infinite space, it's practically in our cosmic backyard, relatively speaking. However, no explorer would likely ever take courage to embark on such an impossibly long journey to meet their cosmic clone. In the 1920s, astronomer Edwin Hubble made a discovery that revolutionized our understanding of the cosmos. He observed that our universe is not static and fixed in place. Everywhere he looked, it appeared that the universe was moving away from us. The farther he looked, the faster those distant galaxies seemed to be receding. Hubble concluded that this could only happen if the entire universe itself was expanding. If we assume that this slab of concrete represents a distant galaxy that is stationary, I could send it a message. I could transmit intergalactic images at the speed of light, and if we wait long enough, they would eventually arrive there. But because the universe is constantly expanding, to make this more realistic, we need to set it in motion. This distant galaxy is actually moving away from me. The farther we try to reach from ourselves, the faster the space between here and there expands. Eventually, a point is reached where that space expands faster than the speed of light. This means we cannot reach there, nor can we see anything beyond that point. For me, the biggest obstacle is this cosmic horizon, which prevents me from reaching the copies of myself and my friends scattered throughout the infinite universe. If I could meet them, it would be absolutely fascinating. But there's one place where we might observe parallel worlds, not in the depths of our vast universe, but in the microcosmos right under our noses, where nothing is actually solid. Frank Tipler is studying the peculiar laws of quantum mechanics, the laws that govern all the atomic particles from which we are constructed. Thank you, Adam. He powers his extraordinary mind with the finest cuisine New Orleans has to offer. Today, I'm in the mood to eat Schrödinger's special dish. Every reality has been described by quantum mechanics, and the central equation of quantum mechanics is the Schrödinger equation. When Erwin Schrödinger formulated the equation that bears his name, he revealed a truth we all now accept. He proved that all atomic particles can exist in multiple places at the same time. He also stated that multiple particles can occupy the same location simultaneously. This entire atomic world remains hidden in a fog, probabilities until someone observes it, at which point the probabilities collapse into reality. Frank believes that this quantum fuzziness isn't confined merely to the microscopic domain, but rather this is how everything actually works. People say that what quantum mechanics tells us about the universe is complete nonsense. But anyone who looks at this Schrödinger equation believes it applies to everything. Not just atoms, but also to buildings, the glass in their windows, and the entire universe itself. If Frank is correct, then everything becomes schizophrenic when no one is observing it, constantly shifting between its many possible forms. Under this steel cover is every dish that Frank could possibly order. But only when Frank removes the cover and observes it does the reality become fixed. What a delight, oysters! But why only this dish? Why not another? Most scientists believe that Frank's observation forces nature to suddenly make a choice. In the blink of an eye, every possible reality changes. But Frank believes their interpretation is incorrect. He concluded that when we take a measurement, there are many possible universes that all become real in a single actual universe. But this understanding is not correct according to the mathematics of quantum mechanics. Frank believes that every possible outcome becomes a reality in its own parallel universe. In this universe, Frank is eating oysters, but in another, he's eating kebabs. In a third, shrimp jambalaya arrived. We've known from the beginning that there are actually many universes, but physicists don't trust their own equations. If Frank is right, then in the space you inhabit, there exists an infinite ocean of your identical copies. If something happens to you, the exact opposite might be happening to one of your hidden twins. But they can't remain hidden forever. On this silicon chip, there's a tiny object that can be real in two places at the same time. For the first time, this scientist has glimpsed a parallel universe. Alternate realities don't necessarily have to be many light years away in the universe. They could be right in front of us. If the peculiar laws of quantum mechanics are correct, then I too am a collection of countless alter egos, and they are constantly struggling. We don't even notice this internal battle. At any particular moment, we have only one reality. All the others are completely invisible to us, or are they? Physicist Frank Tipler believes that quantum mechanics is correct in stating that our countless versions exist in parallel universes. Like many of us, he also dreams of an alter ego. Let's once again journey through the universe. With us is fearless Frank, astrophysicist and cosmic adventure enthusiast. This week, Frank has discovered a portal to quantum parallel universes. Frank Tipler believes our universe is like this cartoon, which we accept as reality. When viewed from the front, a cartoon appears as a single object, but it's actually made up of individual cells. We can use one transparency to represent one universe. But the truth is that countless universes are superimposed upon one another. An invisible object can exist in multiple places simultaneously. According to Frank, each of these becomes reality in its own parallel universe. Whenever we take a measurement, each Frank Tipler's image yields a specific result. In one universe, something appears to be in only one place from our perspective, and it seems that our observation eliminates all other possibilities. But what appears might also be a deception. We shouldn't view possibilities as merely possibilities. Other realities don't cease to exist just because I've grasped one in my hand. They are there. They exist. Asterisk if we could see all universes at once. Countless versions of Frank Tipler would all be taking the same measurement simultaneously. Each Frank would see that object in a slightly different location. These small differences become amplified over time, resulting in different outcomes in parallel worlds. In one universe, an asteroid doesn't hit Earth and the dinosaurs survive. In another, due to a rocket failure, America loses the race to reach the moon. But how will we know if those alternate realities truly exist, since they seem to disappear the moment we observe them? Asterisk, we might never see these quantum mechanical effects of something being in two places at once because we're always measuring things. When air molecules collide with something, that too is a measurement. When we shine light on something, that's also a measurement. If something is resting on a table, the table is pushing against that object, and that's also a measurement. Experimental physicist Andrew Cleland might be the first person to have glimpsed a parallel universe. Asterisk inside this small silicon square. Andrew has installed a metal paddle that isn't even visible. It's made of several hundred billion atoms. In reality, this is the Godzilla of the quantum world. And they want to show us that even something this large obeys the laws of quantum mechanics. We know that the laws of quantum mechanics apply to small things like electrons and atoms. But we have great difficulty believing they apply to large objects, to our everyday objects. But proving that this will also behave quantum mechanically requires ensuring that nothing measures it. It must be kept in complete isolation and must be extremely cold. Asterisk, this instrument is also a dilution refrigerator. And if you have about $15,000, you can install one in your home. This instrument has multiple temperature stages that can measure from 1 Kelvin to 0.6 Kelvin, and from 0.1 Kelvin to 20 millikelvin, which is minus 273.15 degrees Celsius. We perform quantum experiments at that temperature. Inside this dilution refrigerator, Andrew applies a quantum of energy to the paddle. There's a 50-50 probability that it will absorb that energy or not absorb it. But they were astounded to discover that the paddle both absorbed and rejected the energy simultaneously. It began oscillating between these two realities. Asterisk, the paddle was in both states. The state where it received no energy and the state where it received a unit of energy. When it was in both these states simultaneously, it vibrated approximately 600 million times per second. Andrew's groundbreaking experiment proved that the laws of quantum mechanics apply to everything in our universe, whether they're tiny particles or massive galaxies. Regardless of their size, objects can exist in multiple places at the same time. Asterisk, I hope that people within the physics community will accept this. But I don't think people outside the small community I work in will accept it. This was shocking. Many different interpretations have been offered to explain this. One of them is the many worlds or parallel universes interpretation. But they don't prove anything because we can't detect them, so we can't test them. In this sense, people can choose whatever interpretation they prefer. If quantum parallel universes truly exist, Andrew's experiment will be the first step toward understanding their secrets. Asterisk, but there's another parallel world that nearly every scientist agrees exists. It's actually made of antimatter, and if we ever encountered it, it would be a day of catastrophic destruction for us. Something extremely dangerous is moving through our universe, called antimatter. If even a tiny drop of it comes into contact with normal matter, it would create an explosion larger than the one at Hiroshima. The most terrifying truth is that the Big Bang probably created equal amounts of antimatter and matter. We could say that our universe might have an antimatter twin that could destroy the entire world, annihilate everything. But the problem is that this dangerous antimatter universe has disappeared. Asterisk Joanne. Hewitt is a theoretical physicist at the Stanford Linear Accelerator in California. She's a detective searching for that missing parallel universe. Where did it go? This is one of science's greatest mysteries today. Where did all the antimatter disappear? Every particle has an associated antiparticle. It has the same mass as its parent particle, but its properties are exactly opposite. For instance, an electron has an electric charge. Similarly, an anti-electron, which is a positron, has a positive electric charge. Asterisk when matter and antimatter collide. They annihilate in a tremendous explosion, releasing a powerful burst of energy. Boom. If the Big Bang created equal amounts of antimatter and matter, then one of two things must have happened. If antimatter and matter particles collided, they would have completely annihilated each other. But it's possible that some antimatter and matter never collided. Perhaps their explosive meeting is still to come. Joanne wants to find out. She has weaponized Stanford's 3-kilometer-long particle accelerator to recreate a miniature version of the Big Bang. Asterisk. We created two beams of particles and collided them with enough energy to create a pair of particles called B mesons. Inside this experiment called the B factory, Joanne and her team of scientists observed a burst of B mesons along with their antimatter twins called anti-B mesons. They began searching for even the slightest difference between these identical but opposite particles. If you want to study B mesons versus anti-B mesons, you need to observe the time difference when they decay. But they only exist for a very brief moment, making them extremely difficult to study. Asterisk with the help of these sophisticated instruments. Joanne and her team discovered a very slight difference between B and anti-B. One of them decays more quickly or in a slightly different way than the other. Among these, the anti-B meson decays more rapidly. This tiny difference between matter and antimatter would have had a significant impact on what happened after the Big Bang. In truth, it created a completely different universe. Asterisk. Let's imagine that a game of checkers is being played between matter and antimatter, a fight to the death. Both players start with equal numbers. Over time, checkers and anti-checkers eliminate each other. But in the end, one player prevails by a very small margin and achieves victory. From the enormous group created after the Big Bang, this single checker piece survived, and within it is contained all the matter content of the entire universe. The matter we see in today's universe is just a tiny fraction of the two vast oceans of matter and antimatter. If there hadn't been that tiny difference between them, they probably would have completely annihilated each other. This was the same difference that Joanne and her team observed between B and anti-B mesons. Asterisk, because antimatter decays slightly faster, we still have matter today. But this is only a very small fraction of the matter. Created from the Big Bang, this means Joanne's detective work was successful. Now we don't need to worry that a dangerous antimatter universe is hiding somewhere in the dark depths of space, waiting to destroy us. But this story doesn't end here because the results from the B factory can tell us where most of the antimatter is. Unfortunately, we can't say the same about all the missing antimatter in the universe. There's still a part of physics that we'll need to explore in the future. Asterisk, perhaps that exploration will happen soon. In May 2011, the Space Shuttle Endeavour delivered a massive particle detector, the AMS, to the International Space Station. The AMS will search for cosmic rays that were created several 100 million years ago, back when matter and antimatter were annihilating each other after the Big Bang. If any survived, perhaps through this we can reach the remnants of that primordial ocean of antimatter. The antimatter universe isn't the only threat lurking at the edges of our universe. It's possible that we're surrounded by many types of parallel universes, and figuring out what and where they are isn't just a theoretical game. The future of our entire universe depends on this very question. Asterisk, do we have another version or not? Why should we care so much about this? We can never meet them face to face. But these alter egos are extremely important because they might provide the answer to the biggest question about our existence. How was this universe born and how will it end? Cosmologist Andre Lin believes he has made a shocking discovery. According to him, the same force that created our universe also created many other parallel universes. And that same force will one day destroy everything we see. He made this discovery while trying to answer a rather simple question. Why does the universe appear the same everywhere we look? This question has troubled physicists for hundreds of years. Andre believed that a tremendously chaotic explosion couldn't create this smooth and uniform universe we see today. According to physics, everything we see today was created from something the size of a grain of sugar. I think that according to the standard Big Bang theory, to create the galaxies around us would require at least 10 to the 385th tons of high-energy explosives. That would create trillions upon trillions upon trillions upon trillions of tons of matter. This seems completely unbelievable, and that's why it was necessary to tell a different story. And thus the inflationary theory was born. Asterisk inflation is a process that Andre knows very well. And it's not just the force that could blow up the entire universe. When he's not decoding the mysteries of the Big Bang, he inflates the small and large parts of our world with his other passion, photography. This is an amazing camera. When I turned 60, my family gave me this gift for my birthday. I've been obsessed with it ever since. According to Andre's theory, when the universe was as small as a grain of sugar, it was filled with enormous energy. Every microscopic part was different from the others. Like a technical patched asterisk inside this cube are different sizes and different colors. But what happens in inflation is that if we start from a small corner of this sugar cube, it begins to look like a portion of the universe. When we look around from inside this sugar cube, it appears that everything around us is white. Everything around us is pink. How beautiful our universe is. How uniform it is, and we've solved every problem. But perhaps inflation can't solve all our problems. Because once inflation begins, it continues to grow relentlessly, just like Andre's addiction to photography. Asterisk, the universe is also growing day by day. But according to Andre, inflation might strike even our expanded universe. It attacks a small portion of the universe, expands it, and creates a new universe. What happens is that a completely new bubble forms and it engulfs us and destroys us. So is that how we'll end? If Andre is right, then our universe is completely unstable. At any moment, a small portion of it could expand to become as large as the universe and everything in it will be destroyed. Asterisk, but beyond this, one of his old colleagues believes that Andre has misunderstood something. Paul Steinhardt is considered the Albert Einstein Professor of Science at Princeton University. This title has only been given to 2 scientists so far. What does this inflation tell us? If we see a possibility countless times, then no theory of this kind can say anything about it. Paul has been working on inflation for decades, trying to develop a new theory. He claims that space has a hidden 4th dimension, and beyond that dimension exists a parallel universe. Asterisk. We can view our 3-dimensional world as a membrane-like surface, connected to a space with an extra 4th spatial dimension. Now, take these 2 newspapers and see how close they are. Those 2 brain worlds, one is ours and the other is the opposite one, are separated by a very small distance, about a millionth of a billionth of an inch. According to Paul's model, our universe exists in a flexible 3-dimensional membrane, or brain world. The other might be extremely close to it, but it's a completely different universe, and it doesn't interact with us. Asterisk, but Paul's question is, what would happen if it did? My colleagues and I began to think that perhaps these 2 brain worlds don't always remain stationary in one place and are moving toward each other, so one day they could collide. The energy generated from that collision, the energy from the motion of the brains, would transform into matter and radiation, and when they separate, they would be filled with hot matter and radiation, just as happened after the Big Bang. In fact, we thought that would also be a Big Bang. That Big Bang would be a collision rather than the beginning of space and time. Asterisk. Paul believes that alien universe is barely an atom's width away from us. It's such a unique world that even the laws of physics are completely different there. Paul feels that we're beginning to find evidence of this. Although we cannot see, touch, or feel the matter of that other brain, we can sense its existence because we can feel its gravity. In the past decade, astronomers have discovered that every galaxy is surrounded by invisible, supermassive sources of gravity. No one knows what these hidden giants are made of. They call it dark matter. Asterisk, the matter in that other brain world, appears to us as dark matter from our vantage point, and it doesn't interact with the light from our side. So, is that dark matter the matter of a parallel universe? Paul believes we might find the answer at the bottom of a black hole. These are the massive sinkholes of space from which nothing can escape their gravity. A lot of matter accumulates in one brain or another, and its gravitational field becomes so strong that it begins to pull the other brain toward that point. When these two meet at that point, a black hole forms there. This means that although they might be separate elsewhere, where they connect, a black hole is created. Asterisk, unveiling the mystery of dark matter is one of the biggest challenges for physics today. Thousands of brilliant minds and hundreds of telescopes are engaged in this effort. Paul believes that when we discover what dark matter is, we'll know whether it exists in another universe or not. Will black holes connect us to parallel worlds? This scientist might have the answer, and if their theory is correct, we might soon be in contact with a parallel universe. Asterisk, about 400 years ago, it was believed that Earth was at the center of the universe. But then a man from the Polish town of Torun changed our thinking entirely. But in the search for our true place in this universe, the great astronomer Nicolaus Copernicus didn't answer one very important question. He didn't tell us where the center of the universe is. Now, another son of that same town feels he has the answer to this question. If his guess is correct, we'll reach the parallel universe from which our universe was born. Asterisk, Nikodem Poplawski has the same revolutionary spirit as his Polish ancestor. He believes that for any new discovery, you need to train continuously and keep your mind cool. After exercising, my body and mind feel refreshed, and after that I think about questions related to the universe. Then I become even more creative. With this intense focus, Nikodem managed to confront a cosmic monster, the black hole. The inner side of its outer edge is called the event horizon, which even light cannot cross. No one knows what lies beyond that point of no return. Asterisk, inside a black hole. Gravity is so strong that it compresses an entire star into a tiny single point. Physicists call this point of infinite density a singularity. If singularity means this, then obviously we don't understand physics very well. I don't like these singularities, and I want to see if there's a mechanism that's simpler and more natural. Like most scientists studying gravity, Nikodem is also a student of Albert Einstein. Einstein said that space and time are woven into a flexible fabric, and he called it SPATIME Katie and Nengen are holding a towel here that represents space-time. Space-time can bend toward one side under the influence of heavy objects. I have this ball which represents the sun for me. The sun has a significant effect on space-time. You can also see how space-time has curved, and its curving is also affecting Earth. Earth is also feeling that curvature of space-time, which is why it orbits the sun. But Einstein believed that matter couldn't distort the fabric of space-time just by bending it this way. Asterisk, besides bending. Space-time has another geometrical property called torsion. Albert Einstein and mathematician Élie Cartan believed that matter could also twist each and every fiber of space-time's fabric. But the effect of torsion is so subtle that it can't even be measured. When they couldn't find a way to test it, Einstein and Cartan stopped working on that theory. But Nikodem started where they left off. He applied that theory to the extremely dangerous gravity inside a black hole. where matter spins so rapidly that torsion twists space-time into a coiled spring that could explode at any moment. Asterisk, this is a dying black hole. The tornado appearing in this tube shows how rapidly matter spins at the event horizon. At very high density, torsion begins to show its effect and becomes a force that opposes gravitational attraction. When matter moves toward the center of that black hole, torsion increases so much that it spins the matter very rapidly. The matter doesn't fall to a single point. In fact, the center of the black hole itself begins to spin like a vortex. That matter can't just disappear, and it's necessary to conserve energy. In this way, all the matter emerging from a black hole's event horizon goes into a growing white hole on its other side. Attempting to create a new universe, asterisk if Nicodem is correct. Then when mass begins to enter a black hole, it travels to the other side into a white hole, which is a surging fountain of mass and energy in a new parallel universe. But this doesn't only apply to the black holes in our universe. If we assume that every black hole creates a universe within itself, then obviously our universe was also created in a black hole. That would be in some other universe. Nicodem believes that the Big Bang from which our universe was created was actually a white hole that was formed from the death of a star in another universe, and that universe was our parent. If this is correct, then these two universes would be connected by a cosmic umbilical cord that no one has yet cut. If we're inside a black hole, then there must surely be some connection between our universe and that parent universe. Has this scientist reached the bridge to another universe? Does the sudden appearance of bursts of energy in the night sky tell us something more? Could it be a message from the inhabitants of a parallel universe? Asterisk black holes are the most terrifying things in our universe. If something goes inside them, it never comes back. But where does it go? The answer is perhaps to another universe. If we accept this as correct, then perhaps black holes are an excellent medium for sending messages to a parallel universe. Or perhaps it's also possible that inhabitants of other universes have tried to contact us countless times. Physicist Nicodem Poplawski believes that our universe is at the bottom of a black hole in a parallel world. Now he's trying to find out whether the inhabitants of that universe can communicate with us. Asterisk, you can see what happens to matter and energy when they enter a black hole. The gravity inside is so tremendous that if someone went inside, it would separate every atom of their body. But that doesn't mean nothing can survive it. And now watch, I'm going to write space-time in Polish language. There it is. Now I'll tear it into pieces and put it in a blender. And then I'll close it and press the button. No matter how long I keep the button pressed, this information will remain inside. Yes, it has become so distorted that we can't read it. Obviously, this is inside the black hole, and these will emerge from the other side in a white hole. And we can hope that one day someone will be able to read this information. Asterisk, are our cosmic parents sending us messages? Nicodem thinks we have some evidence that they have sent messages. For decades, astronomers have been seeing tremendous flashes of energy in the sky that come from the far edge of the universe. Gamma ray bursts are the brightest explosions. These are the most powerful explosions in our universe after the Big Bang, but we still haven't understood the mechanism by which those explosions occur. They actually arrive after quite some time, and it's possible that they are matter coming from our parent universe into our universe. Could these flashes of energy be Morse code from inhabitants of another universe? A message sent from that cosmic wisdom that is the result of experience from hundreds of millions of years before the formation of our universe. Nicodem's theory is still quite new, and the calculations are extremely difficult. He could be wrong. But this search for parallel universes is now emerging from the world of fantasy to become a serious scientific possibility. And he's not alone in this search. Asterisk, if we consider the full multiverse point of view, we'll see a completely new picture. Whenever two different events occur, we become aware of one. We mistakenly assume that the second event didn't happen at all, whereas another copy of us sees exactly the opposite. We're now debating things that were once considered science fiction. We're now thinking about it quite seriously, and we fully hope that one day we'll get answers to. Asterisk, the universe means everything that exists. Today, we've almost accepted that our universe is not alone. Rather, it may contain many parallel versions of itself. There may be many parallel versions of me. There may be many parallel versions of you, and there may be many parallel Earths. We think about what our alter ego might be like. Are they fulfilling our biggest dream or not? But we shouldn't forget that perhaps in some other parallel universe, you are in the process of fulfilling the dreams of your other form. Asterisk, the concept of parallel universes challenges everything we thought we knew about reality. For centuries, humans believed that the universe we observe is all there is, a single unified cosmos governed by consistent laws of physics. But modern science is revealing that reality might be far stranger and more complex than we ever imagined. The mathematical frameworks we use to describe the fundamental nature of existence, from quantum mechanics to cosmology, all seem to point toward the same startling conclusion. Our universe may be just one among countless others. Asterisk, the implications of this are profound and far-reaching. If parallel universes exist, they fundamentally change our understanding of existence itself. Questions about determinism and free will take on new dimensions. Every choice you make might spawn a new universe where you made a different decision. Every random quantum event might create a branching point in reality. The version of you reading these words right now might be just one of infinite versions, each experiencing a slightly or dramatically different reality. Asterisk, consider the profound philosophical implications. In one universe, you might have become a famous scientist, solving problems that have plagued humanity for generations. In another, you might have pursued art and created masterpieces that moved millions. In yet another, you might have taken a different path entirely, leading to outcomes you can barely imagine from your current perspective. Each of these versions is equally real, equally valid, equally you in some fundamental sense. Asterisk, the mathematics supporting these ideas is rigorous and elegant. Quantum mechanics, one of the most successful theories in the history of science, describes reality in terms of probability waves that collapse upon observation. But what if they don't actually collapse? What if, instead, every possible outcome actually occurs, just in different branches of reality? This interpretation, known as the many worlds interpretation, was first proposed by physicist Hugh Everett in 1957. At the time, it seemed like wild speculation, but over the decades, more and more physicists have come to take it seriously. Asterisk, the experimental evidence continues to mount. Quantum computers, which exploit the strange properties of quantum mechanics to perform calculations impossible for classical computers, may actually be harnessing the computing power of parallel universes. When a quantum computer performs a calculation, it might be distributing the work across countless parallel versions of itself, each solving a small part of the problem before the answers are somehow combined back into our universe. This isn't just theoretical speculation. It's a working model that helps us understand how these remarkable machines actually function. Asterisk, string theory. One of the leading candidates for a theory of everything that would unite quantum mechanics and general relativity also suggests the existence of parallel universes. In string theory, the fundamental building blocks of reality aren't particles, but tiny vibrating strings of energy. The way these strings vibrate determines what kind of particle they appear to be. But string theory requires extra dimensions of space beyond the three we experience. These extra dimensions might be curled up incredibly small, but they could also be large, potentially containing entire other universes. Asterisk, the cosmological evidence is equally compelling. Observations of the cosmic microwave background radiation, the afterglow of the Big Bang, reveal patterns that some cosmologists interpret as potential evidence of collisions between our universe and others. These patterns appear as unusual cold spots in the otherwise uniform radiation that fills space. While conventional explanations exist for these anomalies, the possibility that they represent scars from cosmic collisions with neighboring universes cannot be ruled out. asterisk inflation theory, which explains the large-scale uniformity of the universe, also naturally leads to the concept of parallel universes. According to inflation, the universe underwent a period of exponential expansion in the first fraction of a second after the Big Bang. But if inflation could start, what would stop it? The most natural answer is that it didn't stop everywhere. While inflation ended in our region of space, allowing galaxies and stars to form, it might continue elsewhere, creating an eternal process that spawns infinite universes, each potentially with different physical laws and constants. Asterisk. This concept of eternal inflation creates what cosmologists call the multiverse, a vast ensemble of universes, each potentially infinite in extent, each potentially with its own unique properties. In some of these universes, the fundamental constants of nature might be slightly different. The strength of gravity might vary, the charge of the electron might differ, or the number of spatial dimensions might not be 3. Most of these universes would be sterile, unable to support any form of complexity, let alone life. But in a truly infinite multiverse, every possibility, no matter how improbable, must occur somewhere. Asterisk, this leads to a remarkable explanation for one of the deepest mysteries in physics. Why are the fundamental constants of nature so precisely tuned to allow for the existence of life? Change any of these constants by even a tiny amount, and the universe becomes inhospitable. Make gravity slightly stronger, and stars burn out too quickly for life to evolve. Make it weaker, and stars never ignite. Adjust the strength of the electromagnetic force, and atoms cannot form stable molecules. The list goes on and on. Traditionally, this fine-tuning has seemed to demand an explanation. Some have argued it points to design, while others have struggled to explain it through natural processes. But if the multiverse exists, the answer becomes almost trivial. We find ourselves in a universe with these particular constants simply because those are the only universes where observers like us could exist to ask the question. This is known as the anthropic principle, and while controversial, it provides a logically consistent explanation for what otherwise seems like an extraordinary coincidence. Asterisk. The different types of parallel universes that have been proposed by scientists fall into several broad categories. The Level 1 multiverse, proposed by Max Tegmark, consists of regions of space beyond our cosmic horizon. These are not separate universes in a fundamental sense. They're just parts of space so far away that light from them hasn't had time to reach us yet. But in an infinite universe, these distant regions would eventually contain exact copies of everything in our visible universe, including you. Asterisk, the Level 2 multiverse arises from eternal inflation. Different regions where inflation has ended form bubble universes, each potentially with different physical constants and laws. These universes are truly separate from ours, causally disconnected, and potentially governed by entirely different physics. The Level 3 multiverse is the many worlds interpretation of quantum mechanics, where every quantum event spawns new branches of reality, and the Level 4 multiverse is the most speculative of all. It suggests that all mathematically consistent structures have physical existence somewhere, making our universe just one among all possible mathematical structures. Asterisk. Critics argue that the multiverse concept is untestable and therefore not scientific. After all, if other universes are forever beyond our ability to observe or interact with them, how can we ever prove they exist? This is a serious objection, but it may not be as devastating as it first appears. Science has always dealt with unobservable entities, from atoms before they could be directly detected to black holes before we could image them. What matters is whether a theory makes testable predictions, not whether every aspect of it can be directly observed. Asterisk, the multiverse theories do make testable predictions, just not always about the other universes themselves. For instance, eternal inflation makes specific predictions about the pattern of density fluctuations in the early universe. Predictions that have been confirmed by observations of their cosmic microwave background. The many worlds interpretation makes predictions about quantum interference patterns that differ subtly from other interpretations. String theory, while not yet fully testable, makes mathematical predictions that constrain the kinds of universes that can exist within its framework. Moreover, the strongest argument for the multiverse isn't direct evidence, but rather the fact that it emerges naturally from our best theories of physics. Scientists didn't set out to invent parallel universes. They found them lurking in the mathematics of quantum mechanics, relativity, and cosmology. When multiple independent lines of theoretical reasoning all point toward the same conclusion, it deserves to be taken seriously, even if that conclusion seems bizarre or counterintuitive. The search for evidence of parallel universes continues on multiple fronts. Particle physicists at the Large Hadron Collider smash protons together at nearly the speed of light, searching for exotic particles that might hint at extra dimensions or other universes. Astronomers scan the cosmic microwave background for telltale patterns that might indicate our universe has bumped into another. Quantum physicists perform increasingly sophisticated experiments to test the predictions of the many worlds interpretation. Some of the most exciting work involves trying to detect dark matter and dark energy, mysterious substances that make up most of the universe, but whose nature remains unknown. Some theories suggest dark matter might be ordinary matter in a parallel universe, detectable only through its gravitational effects. Others propose that dark energy, the mysterious force accelerating the expansion of the universe, might be evidence of a neighboring universe pushing on ours through higher dimensions. The possibility of parallel universes also raises fascinating questions about the nature of consciousness and personal identity. If there are countless copies of you scattered across the multiverse, which one is the real you? Or are they all equally real, each experiencing their own subjective reality? If a version of you in a parallel universe makes a different choice, are they still you in any meaningful sense? These questions blur the boundaries between physics, philosophy, and even theology. Some philosophers argue that the existence of parallel universes would solve certain logical paradoxes. For instance, if every possible outcome of every event occurs in some universe, then there's no need to explain why this particular sequence of events led to this particular present. Every possible present exists somewhere. Time travel paradoxes might also find resolution in a multiverse framework. If you traveled back in time and prevented your own birth, you wouldn't create a logical contradiction. You'd simply branch into a new universe where you were never born, while the original timeline continues unchanged. The concept of parallel universes has captured the public imagination, precisely because it speaks to deep human longings and fears. We wonder about roads not taken, choices unmade, lives unlived. The multiverse suggests that somewhere, somehow, all those possibilities are real. That version of you who pursued a different career, married a different person, or moved to a different city isn't just a figment of imagination, but an actual person living an actual life in an actual universe. This can be simultaneously comforting and disturbing. It's comforting to think that our mistakes might be corrected in some other reality, that the opportunities we missed were seized by another version of ourselves. But it's disturbing to think that all the good we've done might be undone somewhere else, that for every heroic choice we make, another version of us makes a cowardly one. It challenges our sense of moral responsibility and personal achievement. Yet, perhaps. The most profound implication of parallel universes is what they suggest about the nature of reality itself. For thousands of years, humans have assumed that reality is fundamentally singular, that there's one true state of affairs, one actual world. The multiverse suggests otherwise. Reality might be fundamentally plural, a vast ensemble of possibilities, all equally real, all equally valid. Our sense of living in a single, unique universe might be an illusion, a limitation of our perspective rather than a fundamental truth about existence. This connects to ancient philosophical questions about the nature of possibility and actuality. Aristotle distinguished between potential and actual existence, arguing that while many things are possible, only one thing is actually real at any given moment. The multiverse collapses this distinction, suggesting that everything possible is also actual somewhere. This has echoes in other philosophical traditions, from Leibniz's concept of possible worlds to the Buddhist notion of infinite interconnected realities. Asterisk. The technological implications of parallel universes could be revolutionary. If we could somehow communicate with or access parallel universes, the possibilities would be endless. Imagine being able to consult with alternate versions of ourselves who made different choices and learned different lessons. Imagine accessing resources from other universes or solving problems by distributing the work across multiple realities. While this remains pure speculation, quantum computing already hints at how we might exploit the multiverse for practical purposes. Asterisk. There are also profound implications for the search for extraterrestrial intelligence. If parallel universes exist, then the question isn't just whether we're alone in this universe, but whether we're alone in the multiverse. Even if life is rare in our universe, there might be infinite universes where it's common. Somewhere in the vast ensemble of realities, there might be universes teeming with civilizations, some far more advanced than ours. The ultimate question of our cosmic significance becomes even more complex in a multiverse context. Religious and spiritual traditions have long contemplated ideas that resonate with the concept of parallel universes. Many traditions speak of multiple planes of existence, alternate realities, or parallel dimensions. Buddhism discusses infinite worlds. Hinduism speaks of endless cycles of creation and destruction. And various mystical traditions describe realms beyond our normal perception. While these spiritual concepts aren't identical to the scientific multiverse, they share a common intuition that reality is vaster and stranger than it appears. This raises interesting questions about the relationship between scientific and spiritual knowledge. Are these different ways of describing the same underlying truth, or are they addressing fundamentally different questions? Science deals with what can be measured and tested, while spirituality often concerns subjective experience and meaning. The multiverse exists at an interesting intersection. It's a scientific hypothesis based on mathematical reasoning. Yet it has profound implications for questions of meaning, purpose, and our place in existence. Asterisk. As we continue to explore these ideas, new technologies and methodologies will be crucial. Advanced telescopes will peer deeper into space and time, perhaps finding more evidence of cosmic collisions or other universes. More powerful particle accelerators might discover new particles or forces that hint at extra dimensions. Quantum computers will push the boundaries of what's possible, potentially giving us new insights into the quantum foundations of reality. And new mathematical tools will help us better understand the implications of our theories. Asterisk. The journey to understand parallel universes is ultimately a journey to understand ourselves and our place in existence. Every question we answer raises new questions. Every mystery we solve reveals deeper mysteries. This is the nature of scientific inquiry, an endless quest for understanding that continually expands our horizons. The possibility of parallel universes represents the current frontier of this quest, a frontier that challenges us to think bigger, stranger, and more imaginatively than ever before. Asterisk. Whether parallel universes ultimately prove to be real or remain an intriguing theoretical possibility. The search for them has already enriched our understanding of reality. It has pushed us to develop new mathematical tools, design new experiments, and ask new questions. It has revealed unexpected connections between different areas of physics and opened up new avenues of investigation. And perhaps most importantly, it has reminded us that reality is likely far stranger and more wonderful than we can currently imagine. That the universe, or multiverse, holds secrets we're only beginning to glimpse. The exploration continues, driven by human curiosity and our endless desire to understand the nature of existence itself.